A/B testing is dead. It's slow, it's expensive, it's suboptimal. We have to send so many users to underperforming variants. But there's good news. The AI renaissance is here to save us. Or at least that's what a number of blogs and software vendors and LinkedIn pundits would want to tell us. They want to talk about multi-armed bandit algorithms as a replacement for randomized controlled experiments. They're more optimal, they're automated, they can do things at scale, and they're machine learning. Do they really help us make better decisions or do things more optimally? That's what we're going to break down in this episode. We'll tell you everything you need to know about multi-armed bandit algorithms and explore where they're actually good replacements for experiments, if anywhere, and what's just hype. I'm Ryan Lecht. I'm the editor of Outperform, joined here, as always, by EPO CEO Chase Sharma and head of statistics engineering, Sven Schmidt. So there's an interesting commonality to any time you hear people talking about A/B testing are dead. It's usually followed by this pitch for multi-armed bandit algorithms. So we should probably just start with what a multi-armed bandit is. And Sven, you are probably most qualified here to break it down for us. So I guess let's just start with the top level concept. Like, what is a bandit algorithm?
Right, that's a great question, and there's many flavors. But I think if you take a step back, the main idea behind a bandit algorithm is that you put an algorithm in some environment that it doesn't know much about, and so it has to learn, but it also wants to learn how to act optimally. So it's trying to explore and understand what's going on, but as it learns, also try to pick actions that work well. And bandits are kind of like, this is kind of a general problem of reinforcement learning, and bandits is kind of the simplest instantiation of that problem, where at every point in time you get to pick an action. Initially, you know nothing about any of those actions, and then as you pick an action, you observe a reward, and then you use that reward to inform, to learn about whether that action is good or bad. And so then by trying all these actions, you're trying to learn which action is actually best. And then you want to play that action more and more often. And so the name multi-armed bandit comes from this history of thinking about this as a slot machine, where there's an arm you can pull. Like, imagine you're in a casino. There's many of such slot machines. You don't know which slot machine works the best, so you just start pulling some arms. And then once you start learning that one slot machine makes you more money, or perhaps rather loses you the least amount of money, you decide, well, I should pull that arm more than the other arm. So it's about dynamically optimizing and finding this optimal balance between initially learning a lot and then slowly moving to exploitation of the best action.
Yeah, and it's worth calling out. Just how does it compare to like the A/B testing thing? Because in all the paradigms, you have an explorer of like, we have options, we don't know much about them. Is this version of the web page better than this version of the web page? We have no data to know it. And then at some point, you're going to exploit the rewards, where it in the biggest way is like you just launch one of them that was better, and then you get to take advantage that it was better forever. And so the big contrast here is a bit of whereas randomized control trials are going to explore with an even split for a period of time and then reap the rewards for infinity, a bandit is going to start eagerly going after winners earlier.
Right, yes.
Yeah.
An experiment is basically explore for a fixed amount of time and then pick an action and basically exploit that action and hope that that was actually the right choice.
Yeah. Exactly. And it's worth calling out, why do we even need more of a dynamic explore-exploit option? We usually, at EPO talk about some canonical cases that, bandits tend to do really well at. So the easiest ones are the ones that have time opportunity cost. And so what is time opportunity cost? It means that, like, suppose you have a news headline, like you're the New York Times, and you want to figure out what is the best news headline for getting readers. Well, if you run the A/B test, by the time you actually figure out which one's better, the news is already passé. It's like been multiple weeks, and we're onto the new news cycle. I mean, we all just saw a crazy rapid iteration of political news cycles that shows you just how fast this stuff moves with the Trump assassination attempt and the new president and everything, or new presidential candidate. So what you need to do in that case is, I can't wait a week or two. I have to start getting some of the benefits, because at that point, who cares if I know the winner 2 weeks later? So you might use a bandit that's going to, in the first day, start to notice which one might be better and start feeding it more traffic and reaping the rewards. So it's time opportunity cost, because news is not long lived. Another time opportunity cost is holiday promos. So an example we give all the time is Black Friday deals, or holiday deals, where it doesn't help to have a holiday deal where the A/B test gives you the answer on December 23rd. You only have 2 days really to reap the rewards of that. So what you need is a bandit to come in and say, okay, I started the test November 1st. I need to start, having the winners be served more traffic much earlier, so that they can start actually purchasing it. Because once, January 1st happens, who cares what was the better holiday deal?
Yeah. So to a layperson, there sounds like there's a lot of sheen on this, right? Like, I'm hearing words that I don't hear when we talk about experiments. We're making decisions algorithmically, automatically. It's machine learning. It's much faster. We can do the optimal things sooner. So what's the catch? Like, why aren't we just using bandits all the time instead of experiments?
Yeah, I think it's a great question. I think bandits are great. They're also very appealing theoretically. I think that's why a lot of people are excited about them, and myself included. I think the mathematics behind it is beautiful. It's a very clean problem, but maybe perhaps a little bit too clean. And the real world is often not as clean as perhaps a bandit might like. So first of all, a bandit really is good at optimizing a single objective, but in many cases, it's not that simple. You can't, if you ask your PM, like, what metric are you trying to optimize? They might tell you, well, we want to increase the number of visitors, but we also want to make sure the slide doesn't slow down, and we also need to make sure that we hit our revenue targets, or whatever, right? Or there's some cost associated. So the objective is often not that simple, and that can be tricky for bandits.
Yeah, and I think it's worth calling that out, because I think a big part of the core appeal of bandits to people is the automated nature of it.
Right.
There's always this sort of discomfort. I run this A/B test, and why is like a human staring at these things and making these launch decisions, these followable humans? But it's worth understanding the reason that humans are involved is that it's not so simple. It's a single metric most often.
Right. And then another downside is that bandits struggle a lot more with what we call time heterogeneity in outcomes. And that's a complicated word for just saying that what people tend to do in the weekends is different than during the weekdays. And maybe in the evening, they act differently from during the day, or rather you have different types of users. And this change in kind of how rewards are shaped throughout time is something that bandits struggle with, because they assume that, or mostly they assume that this is a constant, that there is no such change. And you can try to adjust for this, but it is tricky, and it costs you in basically efficiency that you would gain from learning. You basically lose the edge of bandits learn faster to offset that. Monday is different from a Sunday. So that's another downside of bandits that make it a little bit trickier to use them in the real world.
Yeah, I have a slightly more fundamental question, which is like, as a marketer, when I think of my goals in A/B testing beyond just driving differences in metrics, like, I really want to learn something about my customers. I want to know if, emphasizing free shipping on my product description page, if that drives a difference in checkouts, that means that, like, shipping cost maybe was a real blocker to my customers. It's something they're sensitive to. It's something I need to think about as a marketer, and maybe I want to take that learning and use it in my advertising or use it in other parts of the site. And one of the things I've heard about bandits is we kind of lose that causal learning when we're using a bandit to optimize a problem instead of a controlled experiment, right? Like, I can no longer say with certainty this intervention caused this outcome. Is that correct, or am I thinking about this wrong?
It is certainly a lot trickier with a bandit for subtle reasons. right? Because there is randomness in your data, right? Or in most algorithms, at least there is, or that people use in practice, like Thompson sampling. So you can use that randomness the same way we use it in experiment analysis to get causal inference. But the problem when you run a bandit is that what you do today depends on what happened yesterday, and that depends on what happened the day before. And that makes it much trickier to evaluate what happens because you basically observe a single observation, which is the entire path that the bandit decided to take, because now everything depends on each other. And this makes causal inference trickier, not impossible, but you need much more advanced techniques to get kind of the same kind of robust learnings out that you would have otherwise with an experiment. And an experiment, right, it's basically the easiest case of causal inference. It's very clear, and you don't have to worry about, making these assumptions, using complicated machinery to try and tease it out. It's just right in your face, that causal impact.
I think one of the clearest ways to understand that is like the bandit, you might restart it, just start from the beginning and rerun it and just end up with very different answers.
Right.
Like, because that's not really what a bandit is promising, is some like fully understood, like here's the best of all the things. What you will end up with is among all of your 5-10 options, there's 3 complete losers, just get them out sort of things. And the bandit's going to get them out. And there are maybe 3 or 4 kind of general winners, and the bandit's going to pick one of them. Sort of thing. That's kind of what the bandit's going to deliver you. The A/B test theoretically is going to be gathering enough data and making a bunch of promises around false positives, false negatives, where you might end up with kind of a better, more durable kind of winning candidate. Yeah. But a bandit just gives up on that. It just says, look, there's going to be some things which I have identified as like losers. Let's get them out. And there's some things that are all kind of roughly good, and like it's just going to pick a choice.
So does that mean that the value of the bandit only exists as long as the bandit is still running, right? Like if I turn off a bandit tomorrow, am I going to see benefit a week from now? Like, can I take something away from that that's longer term than just the runtime?
What do you mean by turning off a bandit, right? In general, I think once you start a bandit, you kind of continually want to keep running it, right? Mm-hmm. Like there's no really end of a bandit generally, I think, when you want to put it in production.
And it gets into another of the situations where bandits are very good, because one of the benefits of the A/B testing paradigm is that if you are actually going to make the choice where I got 2 or 3 or 4 options and I need to collapse that to one, because it's just expensive to keep going for a while, right? I mean, the classic case is tech debt. I got this production application. I got a feature flag putting people into multiple groups. It's annoying for my engineers to navigate all these code paths. I want to gather data, make the right decision, but I then want to collapse it to one code path. So an A/B test is perfect for that. It will collapse the thing. Whereas, the bandit, and again, it doesn't make so many promises around like what is the kind of long-term best thing. And the bandit really shines with a kind of continuous exploration. It's continuing to dig into various things and learning about different things. So, we talk all the time about how like, a lot of the best bandit situations are ones where there's no tech debt. There's no debt to hold variations alive for a very, very long time, which you can find in some marketing use cases and some AI use cases, which I'm sure we'll get into later.
Yeah. So if I go back to my imaginary situation, like I'm a marketer, I want to figure out the right free shipping threshold for my e-commerce site. That sounds like that's no longer a bandit use case, right? Because I think there's probably one optimum balance of like free shipping threshold versus the average order value on the site. B, I think it would be pretty logistically difficult to keep offering different free shipping thresholds to different people. At least the accounting on that sounds like a nightmare for my team. I probably just want to use an experiment to find the one right answer there and implement it long term. I don't want to keep
I'm curious what Sven would think, because I actually think that might be a good bandit use case.
Yeah?
And so the reasons why I'd say it is like, one, what is the debt of keeping a variable free shipping threshold up? I'm guessing it's not too much. I mean, if you just have values like, just mark the things that got free shipping, mark the ones that didn't, that's general paradigm that's going to exist in code for a while. And 2 is that the world is going to change. And so the generalizability around like, is this the best free shipping threshold for all of eternity might not be true. I think a little bit around A/B testing is great if it looks a little bit like the laws of physics, where like it is true that removing a whole page that you had to click into to get to the next thing is always going to be lower friction and better. Whereas if it's something where in this season, the summer season, where shipping costs are high, it turns out that the threshold is going to be different than the fall where it's different, or the holidays, like it's actually might be variable over time, because, one of the classic issues with A/B tests is that you measure a short-term window, and, you always have to kind of hope and pray that it generalizes forever.
Yeah, I want to let Sven answer, and then we are going to treat whatever your answer to this question is as gospel truth.
Yeah.
And, it'll be the only answer for free shipping tests for eternity. But I will say, like, when I was consulting with like major CPG companies, it was a concern to the finance department. Like, free shipping means we're losing money on our margins, right? And they had to really consider the sort of like volume versus margin trade-off. And I think like finance departments wanted some predictability in that. I guess this also like could lead us onto a tangent in like making sure you're measuring the right metrics, right? Like revenue is probably not the right metric to measure there. You need to get down to like the profit level
Yeah.
to really understand what to optimize for. But at any rate, I'm curious to get your take on this conundrum we've introduced, Sven. Like, would you use a bandit to optimize free shipping thresholds?
I mean, if my answer is going to be the gospel, then I'm going to say no comment. But otherwise, I think this is an interesting case. I think there's some interesting points raised about things might change over time. And we just said bandits aren't very good at that either. So I think, right, you have to adjust your bandit algorithm at least a little bit. I can see the benefit of having an algorithm constantly adapt, particularly if you think conditions change over time. If you appropriately adjust your bandit, this might be a good reason. It doesn't really perhaps help you learn as much as you would running experiments. I think the other thing that we haven't talked about as a downside about bandits that I would be worried about in this particular case, offering free shipping, is that often, right, companies often have a profit motive, or maybe they just want to make customers as happy as possible. But at the same time, right, customers like to get the best deal, right? They play this game too. They are not coin flippers, right? They can be adversarial and try to cheat the system. And I think if you randomly sometimes give people free shipping and other times you don't, I'm going to refresh the page once I figure that out, right? And so I think that's one thing you have to watch out for with bandits much more than experiments, because in experiments it's much easier to make sure people have a consistent experience. So if I come back tomorrow, I don't suddenly get this free shipping if I didn't get it today. But with a bandit, that might be the case. And I think that interaction can be quite tricky, and so I would worry about that in the free shipping case, or any case where you are using a bandit that has to do with monetary rewards. I have this anecdote from I don't know if you guys know MealPal. That was kind of a thing in about 10 years ago when I was interning at Stitch Fix. There was this company called MealPal. My colleagues were saying, "Oh, you should sign up for this. You can get kind of a discount on lunch." And you know what you should do? You should kind of go halfway through that sign-up flow, but then don't convert, because they're going to send you an email every day with an offer. And sometimes it's a low offer and sometimes it's a high offer, but you could get like $100 off. And this sounds kind of like, I'm not sure. I doubt they used the bandit, but it reminds me of bandits. And every day I got this email, $25 off, $50 off, $25 off. But I heard you could get this $100 off. So I was waiting. I never converted, right?
Yeah.
I never got that $100. I don't know why. But right, like people will start interacting with a bandit algorithm, perhaps in interesting ways, especially when there's monetary aspects to it. So I think that's another reason to really watch out for using kind of algorithms that think things are stochastic when they are adversarial. And now someone might comment, obviously you have the adversarial bandit algorithms too. I don't think they quite apply in this case. But I think that's something definitely to keep in mind as a downside in some cases when trying to think about whether bandit algorithms are a good idea.
Yeah.
Yeah, it reminds me of the Airbnb. We had the guest fee and the host fee. And the reason we were able to kind of run a bunch of experiments and change the algorithms behind the fees and eventually make a lot more money is that we purposely just left it opaque of like, what is the fee policy?
Right.
There was never some idea of like, here's the, percents, some global, free shipping threshold or anything. It was just like, no, it's going to be arbitrary. It's going to be between 5 and 10%, an algorithm's doing it. Under the hood, nothing was changing, but, except for the random noise thing until later. But yeah, just making sure that there's not some expectation of like, oh, just wait and then it'll change.
Right.
The other side that this example makes me think of, that's Sven talking about all the time, is, with bandits, it's also good to try to pick something that's a little bit lower stakes.
Right.
Because the bandit's going to make mistakes. It's definitely going to. You can think of it as just sort of like, I got two young kids just kind of like poking around things, then realizing one of them's going to give candy, and then like doing more of the give candy thing, right? It's basically, what it's going to do. And so it's going to make a bunch of mistakes. Right. So like when you're talking about something where it's like, we got to watch our margins very, very closely, perhaps that's actually the thing where you want the scrutinized A/B test, the human looking at it, than a kind of robot toddler out there just like putting offers out in front of people.
Right. Yep. It's much more of a black box.
Yep.
Great
so
follow-up.
I guess before we get to the meta level of this whole conversation, I feel like we've done a pretty good job of covering the downsides of bandit algorithms, or like the cases where it's a little too messy for them to apply. What about like the situations where they really shine? We talked about just where time is scarce, right? You have a very time sensitive thing like a news headline or a Black Friday promotion. What are some other signals that tell us like, hey, bandit algorithms might be a great tool for this use case?
I think that really is the main one. The other thing that I would say that experiments aren't super good at is personalization, right? In the sense that you really are testing often, right? Everyone gets the same experience, right? And you want to figure out what that experience is. And maybe that experience could be, right, some kind of recommendation system that then obviously like changes things for everyone. So it doesn't mean that everyone actually sees exactly the same thing, but still you're trying to look at one thing that is best for everyone. And there are obviously some more advanced bandit models, such as contextual bandits, right, that try to learn not just what is best overall, but what is best in particular situations. And so I think there are some use cases there where you should really compare them more with recommendation systems than experimentation, where I think there are some cool use cases there too. So I think that's worth pointing out that, experiments are kind of in this bucket of trying to find a single best thing. And if you go into more advanced bandit algorithms, you can do more than that.
Yeah, the personalization side is pretty interesting because another way of saying it is, suppose you got the decision between two types of copy, two types of images. What if there aren't really meaningful overall differences of success between two images, but there's actually a bunch of segmentation-wise heterogeneous treatment effects, as we say
Exactly.
in the biz, where people on mobile want certain things, desktop want certain things, older people want certain things, younger people want certain things, and it turns out the differences between those segments is actually a much bigger order thing, a much more significant change than the overall efficacy of the images against each other.
Right.
Yeah, which happens all the time. And it gets back into the, there's certain use cases that we believe in marketing and AI where like there aren't necessarily universal bests. There are kind of situational bests. And if the tech debt is low to maintain 10, 100 variations, then you can really mine these sort of segment-wise differences more than trying to collapse the space into one variation.
Yeah. So I'm clearly getting that there's like a fair amount of nuance in when bandits are the right tool for the job, right? They are a specific tool with specific use cases where they really shine. But I think nonetheless, like we started this conversation by talking about how much allure there is to bandit algorithms, especially in like online discourse. There's a lot of suggestion that, bandits are universally better than A/B experiments. Maybe we should be replacing A/B testing with bandit algorithms. Or even if not that, like just everyone wants to get involved with bandits in some way. They're very exciting. And I think between the two of you, we have two very interesting perspectives on why that is, right? From the CEO of a SaaS company. Why are there so many companies popping up around bandit algorithms? Why do so many people want to buy bandit algorithms? And as a statistics engineer, like, why are they so enticing just from someone who's like day to day with these tools? So Shay, maybe we can start with you on this one, but like where does the luster come from?
Yeah, I think the luster, the thing about bandits is it actually has a few ways to get eyeballs and attention. So the way I think we hear about the most is, and this gets at the core of the experimentation system, where experiments exist, and I put them in two buckets. One is like kind of optimization experiments. These are things that there's just this internal feel that we shouldn't be spending a lot of mind share on, like a red, blue button color test or a copy test or, it's just kind of low stakes decisions that we don't think are worth a lot of human capital to actually be babysitting them and optimizing them. And so I think in general, there's an allure to how can we make those more automated? How can we make it so that we can still get those metric benefits, but not, have to spend so much time on it. And I'm very sympathetic to that, to be clear. I mean, I really do think that there's a lot of experiments that should be much more automated and get much less mind share so you can focus on kind of more strategic ideas. The place that can be a little confusing when we talk about these low stakes ideas is you can just run an A/B test that has automated rollout. Basically you don't need a Bandit to have automation. It's something I've spoken quite a lot with Martin Tingley from Netflix about. I know something that's hot in their team's mind. But the idea that if you can just prescribe here's how to make a decision at the end, run the experiment and just kind of roll it out according to that protocol, then you can end up with the automation you seek. Now, it might be the case that what we just talked about, the kind of cross-segment differences are more meaningful than the cross-variant differences, in which case you might want to mine those heterogeneous treatment effects with contextual bandits. But, by and large, you can get automation in multiple ways. So I think that's the first one. And then the second is that, the idea that you can kind of rapidly shut off things, I think is, again, a sort of very appealing thing about bandits. I remember way back in the day, I was doing an interview at Open Door, which is a kind of, I like to call them high frequency real estate flipping, right? They buy houses and they try to sell them within 30 days. And the world gets very expensive for them if they ever end up holding houses for more than 30 days. It's kind of the way the business works. They were looking a lot at bandit algorithms with this idea that it's very expensive when the algorithm is bad. Can we shut off bad algorithms fast? Now, Sven, you and I have spoken before that even with that allure, bandits might not be a good fit for Open Door because of the transaction cycle takes a month or something. Ideally with bandits, you want a within session transaction cycle. And again, you want stuff that's low stakes because the bandit is just going to be a blind toddler out there. But again, there is this sort of allure of can we shut down the bad things automatically, quickly? Which again, there's other solutions. There's more other ways to get this sort of automation. But I think that's kind of the two veins I see most often. And then, of course, multi-arm bandits just has a very sexy name. Right? Some of these algorithms, the machine learning world is always great at that, deep learning, as opposed to regression in the stats world. But I think there's a few things that make people attracted to bandits.
Yeah, I think I really resonate with the latter part. In some sense, experimentation, right? The A/B test is 100 years old. Or older. It's fairly boring. It's basic, right? We learn it in Statistics 101. And after that, you can basically analyze an experiment, whereas there is some beautiful kind of mathematical structure to bandits. And I think that is appealing. I think data scientists like to be nerd sniped, partially, right? We tend to gravitate to technical discussions, even though perhaps we should be talking about culture, right? How you build an experimentation culture, for example. But I think, we tend to like these technical problems, and bandits provide that. And I think that is very exciting for people to work on. And if they're excited to work on it, obviously there's a tendency to do that. And I think I understand that. I feel that too. So I think partially just kind of the technical aspect, I think, is alluring to a lot of folks.
Yeah. I alluded to this a little bit in the question, but I'll just call it out specifically. It seems to me like the end users and the use cases for experiments and bandits have a lot of overlap, right? If I need one tool, I probably also need the other in the course of my day-to-day operations. If I'm a marketer, I probably have use cases for both. If I'm a data scientist, I probably have use cases for both. So just to, get a little inside baseball here, it's interesting to me that in the software vendor landscape, there are some vendors that are just bandit algorithm tools that they've, created verticalized products for. And then there are some vendors that are solely focused on experimentation. I'm curious if both of you have a take on why that is, and if that's a natural byproduct of them being two different tools, or if it's something where you think there'll be consolidation in the space over time. Maybe we could start with you, Sven.
Yeah, so I think this, to me, reinforces our point that actually the overlap there might seem to be a lot of overlap, but when you actually go into applications, the overlap isn't actually there. And so I think it's a little bit tricky for a company to, obviously you then want to just focus on one or the other, because they're just quite different use cases. And so, and the other part of it is, I think the systems that you need to build to create an effective bandit algorithm are quite different than the things you want from an experimentation platform, right? In a bandit, you want kind of more real-time feedback in many use cases, right? We talked about the news headline use case, right? News headlines, they are there for most of the day. Probably in a few hours, you want to figure out what to do. Whereas in an experiment, right? Like an experiment often takes 2 weeks. You can run the computation daily. It's just a very different infrastructure. So I think the overlap in kind of problems is quite distinct, in technology is quite distinct. And I think it's also hard to tell the story that you're doing both when they're kind of quite different, in fact, right? Like since the overlap isn't quite there, and I think especially startups want to start off, and Jay, you can vocalize this much better than I can. You want to be focused, right? You want to say, this is the problem I'm solving. And if you're doing both bandits and experimentation at the same time, I think you struggle with telling potential customers what is the problem that you're actually trying to solve, rather than just saying, I'm trying to solve all the problems, which I think is you probably need that focus. But I'm curious what your take is.
Yeah, and both are deep problems. I think what we've seen in the bandit world is that it looked a little bit like the experimentation world kind of before the latest generation of systems, right? Where, it was very heavily indexed on the sort of UX experience of the people setting up the things, like the marketers most often. But then pretty shallow on the actual machinery of what is actually crunching numbers and making decisions and the stats and all that sort of stuff. And I think there's sort of a natural arc of like, the early foray, it's so different, and, they kind of index on this kind of single use case sort of approaches, which leads to a lot more verticalization around a marketer or a certain use case and the UX of setting things up. And then kind of as these systems start to get to be a little bit more understood. You start to show up to a company and the person ran the bandit in their previous company or something like that. That's when, you start to appreciate the depth of it, where you actually want the bandit that's going to perform better. And you want the ability to even know whether it performed better by A/B testing the bandit. So I think that there's just a kind of natural deployment cycle maturity curve of these tools that, like, the earliest versions of bandits sort of required being a bandit-only company. And I think now we're kind of approaching a world where, people actually want kind of greater depth, greater machinery, greater sophistication out of their bandits, and the ability to evaluate them against other approaches.
Well, thank you both for the perspectives. I think we've successfully teased apart the bandit versus experiment thing in good depth. I think the next time you hear someone equating the two and saying that bandits are a replacement for experiments or more optimal, hopefully now you understand that they're, two distinct tools with two different use cases. I'd be remiss if I did not mention on Outperform, we have lots of other great content on bandits versus experiments, including a post from Sven. We have content on the personalization opportunities that contextual bandit algorithms present, how they compare to recommendation systems, or how companies like Netflix and Lyft use contextual bandits in their actual products. So check that out at getepo.com/outperform, or send us your questions if you want to get into more, what ifs on would you use a bandit in this scenario. I think this is a conversation that's not going anywhere anytime soon, given the allure of those bandit algorithms. So we're definitely here to keep having it with you. Thanks for listening to this episode of Outperform. If you're looking for a powerful tool that lets you leverage both bandits and A/B tests, check out Eppo. Eppo's world-class experimentation platform and contextual bandits are trusted by world-class companies like Twitch, DraftKings, and Coinbase. Visit geteppo.com for more info. That's geteppo.com. Until next time, keep experimenting.